What's up, YouTube? R&D Lee here with yet another edition of MBS Tech Talk, focusing on our new electric mountain board series, the MBS Agent. This one, I'm going to go and kind of deep dive into each of the features, each of the components of the MBS Agent, and do it from the perspective of myself, actually, as a designer, as I kind of went through this process of saying, why did we do what we did? Because actually, we ended up with this product that is absolutely amazing. I love it, but there's lots of choices along the way that kind of got us here, and we could have kind of gone different routes, and all those are like valid options. They're really difficult design decisions to make along the way, right? But we went this way because we were going for something badass, and that'll kind of like come through as we talk about these design decisions. You know, you can go for something affordable, you know, that everybody can afford. You can sell millions. You can do lots of different things. But this is going to explain kind of what this is about, just based on the choices that we made through the design process. So the first kind of most obvious decision that we needed to make, we're doing an electric mountain board, right? Where are we going to put the battery? Because most electric boards have the battery underneath. It's, you know, you don't see it. You know, it's, I think, aesthetically more pleasing in general to kind of have it underneath. Serious DIY people, they put it on top because they're serious. They do, like, they push the limits of the sport. They're badass, and they know that a battery needs to sit on top. But because the resources are limited, they got to go with kind of like off-the-shelf options, which are like Pelican cases and things that just like really hurt my eyes. I mean, it's great. I'm cool with utilitarian things. Like I'm an R&D guy. I do that stuff all the time. But when it came time to making this board, this is a production board, and we want it to look absolutely beautiful. So that decision between a top box and a bottom box, even though definitely had to think about it, because there's some companies that, you know, they're doing electric mountain boards technically and putting the battery on the bottom. No go for us. Like I said, aesthetically the easy choice, but for serious mountain boarding, it was not a choice. We had to go with the top box. And doing that, we knew that we had to put a lot of energy into making it as beautiful as possible. So that's number one. Top box, serious mountain boarding, decision number one. Decision number two is that top box going to be permanent or quick swap? Now, what are the trade-offs there? Well, if you make it permanent, you can do it cheap. You know, it's basically just, it's like, you know, some other competitors, you just make a box, bolt it on, done, right? What we've done is a quick swap, these, you know, engineered from the ground up on this box, not just to look beautiful but to be super functional as well. So quick swap, very expensive, but we are looking, whenever we get into something, we're looking kind of like long-term, not only as a sport, we want to see the sport grow, but we want to see this line last a long, long time. So this technology we want to last, and we knew quick swap was the way to do that. Just a real quick, I've shown it in a couple other videos, but the quick swap, you know, truly is pretty quick. As soon as you unplug the thing, the buckles are pretty easy to do. It's just, you know, pinch to unlock that guy, and that's it. The battery just kind of comes off. That's it. And then to pop it back on, it's the same thing, but in reverse. You just got to make sure it's kind of like registered on there. And then you get this guy there, and you get this guy there, and it's done. Well, not done. Sorry, you got to plug it in. Otherwise, you're not going to be going anywhere. Okay, so that's the quick swap technology. It's awesome. It's solid. It's fast. Super duper proud of this. And that was design decision number two. So for design decision number three, kind of sticking with the box, we had to decide on the voltage. So the decision that needed to be made, which was basically, do we go with kind of like the industry standard, which is, 10S, 12S, so they call it 12S for like serious boards, right? Which is like, say, a 50 volt, type of voltage, max voltage. Or do we do the right thing, spoiler alert, what I believe is the right thing, and go higher voltage? Okay, so like I said, I won't go into this in too much detail because I have a whole video that kind of goes through that, but it drives me crazy that you still see manufacturers out there touting high amps. We got this, our, just 200 amps. It's crazy. It doesn't make sense. There's two ways to get high power. High power is what you want, by the way. You're talking about power. You don't care. Voltage doesn't mean anything without amps. Amps doesn't mean anything without voltage. It's the two together. When you multiply them, you get power. And what you feel on a board is power. Power, whether you use it for high speed or for high torque, whatever, you want power, okay? Two ways to get it, amps and volts. Volts is the right one, amps is the bad one. High amps ends up in high losses, high heat, no good. We had to make that decision. So why was it a difficult design decision? Because the physics is not difficult. The physics says you do high voltage. That is definitely what you do. You do not see car companies, electric motorcycles, they all go high voltage. We send electricity across the country with high voltage for a reason, because physics says that is the right thing to do, yeah? So why was it a difficult design decision? Well, when an industry exists, there's a lot of inertia around that 10S, 12S. So when we talk about kind of compatibility and maybe buying parts off the shelf, KVs of motors and those types of things, it's just easy. It's easy to go with that. That's what people kind of understand. So it's kind of like breaking through that inertia. So that's why it's a little bit difficult. But to be honest, it wasn't that difficult, because I believe that this is important. This is a place where MBS could be a leader and saying, you know what, we're done with the low voltage era. This is a high voltage era. In the immortal words of Bon Scott, high voltage, rock and roll. That's what this thing is about, rock and roll. Moving on from the center of the board, taking you over to the rear end here, and what a beautiful rear end it is, with helical steel, fully sealed, O-ring sealed gear drives. Okay, so what was the decision that we had to make there? Well, it's basically gear drive versus belts, all right? What's the trade-off? Belts are cheap. That's why you do belts, because they're like a quarter of the cost. Even more. Like, belts are just cheap. You just dime a dozen, you can do a belt system. Don't get me wrong, belts have their place. MBS offers some kind of like DIY belt drive types of things, just, because they're easy and, some people like them and they can't afford something like this. I get it. Belts have their place, but not on a serious mountain board. Do not get a belt drive if you're actually serious about doing some mountain boarding, because ask anybody, belts break. Belts break all the time because of the actual kind of torque and the high power that you're doing, but not even that, just they're exposed, and even if they're not exposed, stuff kind of gets crammed into the belt. You get dirt in there. As soon as you get a bit of mud or something like that, it kind of gets into the gear and it'll snap your belts. Don't go belts if you actually do an off-road mount. On-road stuff, different. If you got a nice wide belt that can kind of handle the power that you're doing, that's cool. Like I said, I respect it, but if you're mountain boarding, do not get a belt drive. It sucks because it's more expensive to get a gear drive, but you just got to do it. You need something that's sealed that you can bash on rocks and stuff like that. Okay, that's design decision number 4. Digging a little deeper inside the gear drive. Doing a gear drive is one thing, but what you put in there is another thing. So most, say the majority of gear drive designs on the market today, excuse me, use plastic gears, all right? Cheaper? What are the advantages of plastic gears? They're cheaper, and they're also quiet. I kind of like the feel of a plastic gear drive. We tested a ton of them. Don't think we didn't actually think. I really seriously entertained this option, and even went with some of the technology that exists in the market of doing double gears to kind of like spread the load a little bit. We tried everything. It feels nice, there's a lot of advantages, but at the end of the day, it cannot handle the power that we wanted to put into this board. 7.6 kilowatts is a lot of power. And if you're just kind of cruising, it's actually palm gears or plastic gears. It can handle it if you're just kind of cruising. But mountain boarding, you're not cruising. You're jumping and you're landing, and those shock loads, they crack the gears. They just do. We melted gears. We have not only like an intense team of riders, but we have some serious lab testing equipment that run these things day and night, max power, max braking over and over. And with what we're touting this board to do, which is 7.6 kilowatts for this, for the Explorer model, it ranges from 5.3 up to 10.6. With what we're saying this board can do, if we would have done a plastic gear, a palm gear, it would have been disingenuous because you would not have been able to actually do that and have your gear drive survive. This gear drive with a helical steel, chromoly steel, the special little alloy that I talked about in the other one, that will last a lifetime. That's it. You don't have to think about it. You're not going to jump thinking, oh, I wonder if my belt's going to break, or I wonder if my gear's going to break. It's just complete peace of mind. These motors are big. They're badass. They're high torque. They're everything you've ever wanted in a motor. So what was the design decision that went into kind of choosing this motor? Well, it's actually not an obvious choice because a lot of our competitors mostly use kind of smaller motors. Why do they do that? What are the advantages of a small motor versus a big motor? Well, once again, cost. Small motors, there's a lot of cost in a bigger motor. So, small motors are cheaper. That's good, right? That's one advantage. But it's not quite as simple as that, as just saying, hey, we just wanted, to do a badass motor and we didn't care about cost, because there are some other advantages to small motors, and that's weight. There's a lot of weight in this motor back here. So this is one design decision that I really kind of thought about for quite a long time. And even considered having a smaller motor on the Air series, right? In the end, we did a bunch of testing on that. It is nice to have a little less weight in the back end. I do like that. But so this was a tougher decision. In the end, I just went with one badass motor, on both models. And, we'll kind of keep testing the smaller motors, but basically we want this thing to be just, like I said, complete peace of mind. Complete peace of mind. I don't want you having to worry about, oh, I'm riding this pretty hard. Should I check if my motors are hot and I'm going to fry them? Don't worry about it. You're not going to fry these motors. You don't. So it's the same motor on the whole line, and it comes back to the thing that really, won the argument of that design decision, really was just how robust are these motors? Complete peace of mind. So maybe in the future we might do a smaller motors, a freestyle one, if we can kind of get something maybe on a lower power board, or we're still kind of R&D in that, but as it is right now, you got some badass motors that are super high speed. They're doing over 40 miles an hour and have high torque, and that kind of comes to how much energy we've packed into this battery. But these motors, they're solid, they're good. The most difficult design decision of all, it's the elephant in the room. I've already seen comments about this on Instagram. Are you ready? Controversy. It's open source, VESC, or proprietary for our ESC. Like I said, elephant in the room. This is a tough one. This was by far the most difficult decision that we made, because in the early stages of our R&D were all, DIY builds, just me building boards, and thank you so much to the DIY communities for sharing information for my own builds. And that is just, I love that community because they're so forthcoming with information. I hope I've contributed as much, both on the forums and as componentry from MBS. So I hope I've given as much as I've taken from that community. But just shout out there, love you guys. And yeah, so basically within that DIY community, open source is just sacred. And I get that, and I've used it, and I love VESC. But when it came time to do this board, it was really important to me. One of our design kind of constraints is people coming into this agent series, they're doing it for a reason. They're not DIY people. If they were DIY people, you can go and do your own board. You can use all our components. You can build your own battery. That's fantastic. You use open source. But, or do anything you want is the thing. But for our customers, people come to us, they're not really serious DIY people who can build a battery and like manage those things. They just want to ride. Or that's kind of like our vision. Our vision for this board is just people that just want to ride. It's like you want to just buy something on our website and then get it and then ride. You don't want to have to worry about settings. So we kind of balance that out, because with VESC you actually do have to worry about settings, right? Because you can get things wrong. And that was the one thing we did not want with this board. We didn't want you to be able to accidentally tweak something, get it wrong, and get to an overcurrent situation that launches you off your board, super dangerous for you. Get to, something that's going to fry your board, your ESC, or have your battery blow up. It was no-go kind of territory for us. And so that's kind of how we ended up there. We wanted something basically with all the options of VESC, but just with guardrails to kind of keep people, outside or within the safe zone. We don't want them going off the cliff and like damaging themselves or the board. So that's kind of that's what won that argument. That doesn't mean that we would never do a VESC project. Like I said, love VESC, love open source, absolute respect for that. So that's not like something that we're saying, this is the devil and this is way better. I think we've matched VESC performance and adjustability with what we've done on this proprietary ESC. You can still motor learn, you can still do all the things that we really wanted, which was important, we thought was important for even to support the DIY community with all these. And by the way, you can buy, DIY guys, you can buy the battery pack, you can do it with your own VESC, you can buy the gear drives, all that. We're still super committed to supporting the DIY community. The only thing, that is controversial is we did go with the proprietary software on this thing, a proprietary ESC. And we've just done it because we think that is actually the right decision for our customers. The people that want to come, they mostly want to ride, they want to tweak some settings, but they don't want to worry about, whoa, am I gonna get hurt because I get launched off my board, or fry my board, which is a very expensive board and you don't want to fry it. So leave some comments down below. You've already left some pretty intense comments on Instagram about this, so don't hold back. I want it to be a conversation. I really do. Like I said, VESC isn't off the table for us. For future things, we want this, one, sport to grow, but we want this line to grow as well. So this is our first, the first two models in this series. This is not the last. This is kind of a long-term thing for MBS. The only other thing I'd say, design decision-wise, which it wasn't a decision, I mean, it's got MBS components. It's got our amazing matrix trucks, which are just incredibly adjustable. Obviously, F5X bindings, all those types of things. So that wasn't really a decision, but we did make a decision actually to do some innovations. Like we did a new, first of all, just on the truck, we did upgrade our truck. So kind of a CNC version of the truck, which is beautiful. Basically, same shock blocks, same performance, all that type of stuff. We've upgraded the kingpin to have a lock nut be a little bit different. So there's definitely some upgrades, but it's mostly kind of fine tuning the performance that you got out of the Matrix 3. You're getting out of this, so that nothing too major there. But going with the base plate bindings, that is pretty major. We put some pretty expensive molds in use on that, and a lot of design time. We got toe and heel ramps in that thing. We got a 4-hole snowboard disc, which we're hoping is going to be industry standard, because that is really cool. Now you can dial in your stance just down to the degree, and down to like the millimeter, basically, kind of toe heel adjustment. You can go stance width adjustment, you go angle adjustment, you can do anything. So we did decide to actually innovate on some of our normal mountain board products, which is fantastic because that benefits mountain boarders as well. There's lots of other details in there, obviously, little design decisions along the way, but I think those are the main ones. And I hope that kind of like talking through them from my perspective as a designer helps you kind of understand just more about the board and why we did what we did. If you got any questions, please, as always, leave a comment down below. We want to engage. We'll be replying to you. Let's make it a discussion so that we know what you think about this line and what you want to see in the next line, because MBS is in it for the long haul. Thank you so much for watching. R&D Lee, goodbye.